Good evening. This is Whiskey Zero, Delta Delta Zulu. My name is Dave, and I'll be filling in for Kevin for tonight's Northern Colorado Amateur Radio Club TechNet. Tonight's topic is diagnostic equipment. What do I need in my shack? We also have a special speaker, Mark from the Disaster Incident Response Team, or DIRT, who will just kind of tell you about his organization and what they've got going on there. So just to get it started, if I could get a few check-ins. This is Whiskey Zero, Delta Delta Zulu.
Whiskey 2, Mike, India, Charlie, Mark in Loveland. This is KE0 RXF, Randy in Fort Collins.
Good evening, Dave. Kilo Zero, Alpha Bravo Kilo, Alex, Mobile.
This is Kilo Echo Zero, Lima Charlie Kilo, KE0LCK, the other Mike from Windsor.
Kilo Echo Zero, November Papa India, John from North Fort Collins.
Good evening to KC0RBT, W2MIC Mark, KE0RXF Randy, K0ABK Alec, KE0LCK Mike, KE0NPI John, and hopefully I got all those right. Any other check-ins for tonight's Northern Colorado Amateur Radio Club TechNet, please call.
This is K1DEG, Mike in Platteville.
This is Dave. This is Whiskey Zero, Alpha Sierra Papa, Terry in Berthoud. This is Kilo Foxtrot 5 Zulu Foxtrot Mark, guest in Fort Collins.
This is Kilo 5 Kilo Tango Lima Katie, guest in Fort Collins.
This is November 7 Golf Echo Sierra Kevin in Fort Collins. I'm only here for a very short bit, but thanks for Dave for taking the net and for Mark for coming in to share some extra material with us. I'll be out of here in just a few minutes.
Good evening to K1DEG Mike, W0ASP Terry, KF5ZFF Mark, K5 KTL Katie, and N7GES until he's gone Kevin. Any other check-ins, please call now and we'll move on to some topics.
W0DAS.
And good evening to W0DAS Dave. So last week, due to incident weather here and many of our contributors being out working for Skywarn, we did postpone the net. So tonight's topic is going to be the diagnostic equipment. What do I need in my shack? As well as us having a guest speaker tonight. Mark. I am going to pass it to Mark and let him tell you a little bit about what he's got going on. So KF5 ZFF, Mark, the floor is yours.
Thank you, Mike. This is Kilo Foxtrot 5, Zulu Foxtrot, Mark Lehman from Round Rock, Texas. I get to participate in a volunteer group that my company, or at least the company that owns my company, Cisco Systems, runs as part of their Tactical Operations Group. The name of the group is Disaster Incident Response Team, and it's a group of volunteers that are regular Cisco employees that volunteer their time for the tactical operations and preparation and deployment for disaster response communications. The name is DIRT, as in the dirt you would get on your boots if you were out deployed, Delta, India, Romeo, Tango. For those that want to follow along on the web, you could search on the word Cisco, which is the name of the company, Cisco starting with a Charlie, and then the word tactical, followed by the word operations, and the word dirt, and that will take you on a web search to the web page that talks about these kinds of things. Tonight, I will just briefly touch on what the group does, what kind of deployments they've done, and how to get a hold of them. The mission statement is to deliver secure communications solutions globally, providing mission-critical connectivity and support of crisis response and recovery efforts as part of Cisco's corporate social responsibility and thought leadership. Tactical Operations, or TechOps for short, it's TACOps for short, was created in 2003 in Cisco's Research Triangle Park facility for military support. In 2005, the TACOps mission changed to disaster response after Hurricane Katrina. From 2007 to 2014, TACOps expanded throughout the world, and in 2014 started the Texas DIRT organization. That's the one I'm part of. Over this time, TACOps has created several portable communications kits. That's a mouthful. Cisco provides these pieces of equipment and these vehicles and equipment kits to served agencies upon request, free of charge, based on need and availability of equipment. Sometimes the equipment is loaned out with the assistance of a DIRT volunteer. Other times, a DIRT volunteer and here's where I screwed up my writing ahead of time. Other times, DIRT volunteers will travel to a destination to set up vehicles and equipment to the served agency's needs. The core responsibility is and responses are in the order of emergency communications, humanitarian relief, equipment donations, and giving back to the community. In the areas of industry and influence/thought leadership, TACOps attends external events, provides speaking engagements, of which in a small way this training is a part. It also forms strategic partners and develops working groups with other organizations supporting disaster response. The DIRT team is composed of both regular TACOps dedicated Cisco employees, which are about 8 in the U.S., actually 8 worldwide, and regular Cisco employees who have other day jobs, and they are in the between 300 and 3,000 range all over the U.S. Right now, I think we have 350 active DIRT volunteers. And the key locations that equipment and people are deployed from are the original location, Park North, Carolina, which is Research Triangle Park, San Jose, California, Austin, Texas, the UK and Ireland, I don't have the city, Brazil, Greater China, which is Shanghai and Hong Kong. And each DIRT team has their own cache of equipment, such as portable communication kits, portable satellite kits, and satellite phones. And Austin also has emergency communications trailers. Many of the other groups also have trailers, and some of the groups have very large trucks that don't require a certified driver to drive, but any employee who has a typical car driving license can drive. For large-scale network needs, we use our network emergency response vehicles, and those are the NERV trucks. They look like an 18-wheeler, but technically they're just small enough for a typical driver to drive. Can I get a radio check? My wife's looking at me really strange, like she can't hear the transmission coming on the test radio.
Yeah, you're coming through good, Mark. Go ahead. W0DDZ.
Okay, this is KF5ZFF, continuing the training, talking about DIRT. Almost finished, actually, guys. So I had this nice script written up, but here's what the group really does. It's a bunch of people, typically ham volunteers, who do extra work for the company, and it is all volunteer work, but the company does chip in a significant amount of money to provide equipment to a variety of different organizations. A lot of times that equipment is to enable wireless communication and to have like a satellite dish that provides that wider band that retranslates that into a Wi-Fi connection. But other times we'll just send along, for example, when a lot of groups were evacuating Syria, we'd send along equipment for people to typical people that were migrating with the evacuation, and they would have equipment that we would remotely manage, and the evacuees and the refugees could have voice and Wi-Fi connections back to their homes wherever they were going to or coming from, to let people know that they were safe. That's about one of, I think, over 100 different types of deployments that we've done overseas, along the coasts for hurricanes, for different kinds of fires, for different kinds of earthquakes. And Cisco will send the volunteers around the world as long as they have the right level of training. And while the Cisco volunteers are ICS 100, 200, 700, and 800 trained, as well as additional training, typically we hand the reins over to whatever the served agency is so they can do their work. We're the engineers. We get out of the way so they can do their work. And any organization is free to request the uses of the DIRT team, both the volunteers and the equipment, by basically searching on that same link, Cisco Tactical Operations and DIRT, and that will give you a link on who to communicate with. And based on need, we can usually get equipment out fairly quickly, either shipped over on an airplane, or actually if we can drive there, sometimes with a truck. But again, it's based on what people's needs are. So we're not going to send the Cadillac NERV truck to someone who just needs to run 2 or 3 telephones out of a high school basement while people are doing their not CERT, but like CISM type work to debrief people who've been through a disaster. So hopefully this has been helpful information. Just wanted people to know that this kind of group is out there, and if anybody here is actually working for Cisco, like maybe out in the Boulder area or in the Denver area, that's something you can participate. and all you have to have is your manager's approval, and Cisco covers the cost of the rest of the stuff. You're really not supposed to bring your own equipment because we can't depend on any one individual's equipment, so the company spends the big bucks to get it. And then if there's any questions at the discretion of Net Control, I'll hang around and answer questions. Thanks for your time. Back to Net, KF5ZFF.
This is W0DDZ Net Control for tonight's Northern Colorado Amateur Radio Club TechNet. Mark, do you guys work with ARES groups in various areas or just with states?
We pretty much work with any group that has contacted us and said we're a legitimate group and can show. So ARES definitely counts, RACES counts. And in that regard, while we don't have it publicly advertised, we do have equipment to do trunking capabilities. Now that may come or go, but for the ARES groups, that can come in really handy to trunk different radio frequencies together.
Yeah, it's definitely very interesting. It's more in line with the net that would run on Thursdays. The Colorado or the ARES Region 3 District 2 has a net on this frequency on Thursdays at 7, and then Sunday is the state ARES net on the frequency of 145.310, the Colorado connection. Were there any other questions for Mark, KF5ZFF, before we move on? Hearing none. Tonight's topic was diagnostic equipment. What do I need in my shack? And this is an area that I am just starting to dip into. I will start with, I guess, a story. I had just put up a HF antenna because I got my hands on Mark's old ICOM 706, and he was kind enough to bring over his antenna tuner and help me classify my antenna and not antenna tuner, his antenna analyzer, and be able to classify my antenna, and we were able to adjust. So an antenna analyzer is definitely a very nice tool to have. I'm just starting to learn about it, but there's a range of them. Is there anybody who wants to comment on the range of antenna analyzers that are available today and what we should be looking for and purchasing?
This is KF5ZFF. If I could, I'd like to make a comment on that.
Yeah, go ahead, Mark.
I have found that in a pinch out in the field, and for an antenna analyzer that is semi-disposable, that there are some Chinese-made small, very small handheld units. They look like it's about the size of a deck of cards. And they typically are broken into an HF unit and a 2-meter and 70 centimeter. But the benefit is that one can get those for about $100, and they're available on Amazon. I have one, don't have it accessible where I can easily give you the name of it right now, but I have found it to be just as helpful for me to tune a buddy pole out in Colorado City last summer, and it was just as good as a rig expert, or not, I'm sorry, not a rig expert, I can't remember the name of the $5,000 to $1,000 units, but it did come in handy, but obviously not the same quality. KF5ZFF, back to net.
MIC.
I was hoping you would chime in because I believe you had something like that, Mark, at one of the lunches we went to. Please go ahead, W2MIC.
I do indeed. It is called a Mini 60, Mike India November India 60. It is a Chinese clone of the SARC 100. Price on eBay is right around $100. It is a unit. It is about the size of a small pack of cigarettes, as mentioned. It really fits in your shirt pocket, which is great. It does HF through, I believe, 60 megahertz, so it does 6 meters but does not do VHF or UHF. It has a Bluetooth connection, and you can connect to an app on your Android phone, maybe also iPhone, I don't know, and get a graphical display so that you can say, I want to scan from frequency A to frequency B, show me my SWR curve, and bang, on your phone or tablet it appears. Very nice. I'm still testing for accuracy. I can't attest to that yet, but convenience and usability are A+.
So, Mark, is that the only antenna analyzer that you have, or do you have another one that you use on a regular basis?
I also have the oldest of the MFJ line. I have a 259, which is a 160 through 6 plus VHF. It's big, it takes lots of batteries, it's clunky, it works just fine. The newer stuff that will plot a graph for you is way more convenient. How I use mine is I simply dial the frequency back and forth, discover where my frequency of lowest SWR is, and then move the frequency in each direction until I get to the 2 to 1 point. And then that's my usable bandwidth with that antenna as that tuning is. The Mini 60 and the MFJ. The MFJ is actually superior. It does VHF. These days, in the $300 to $400 price range, you can get the MFJ 269, I believe it is, and the 259C. All kinds of cool stuff, and then the price goes up from there.
Yeah, that sounds about what the one that Bart and I used to tune my antenna. We just found our lowest point and worked out the curve from there on a piece of graphing paper. And it was very, it was my first time actually getting to do stuff like that. So it was very interesting to me to see how that was all plotted out. Probably learned a little bit more than just getting the graph from the larger antenna analyzer, but the convenience of that larger antenna analyzer, I could see how much more convenient it could be. Does anybody have a rig expert or one of the larger antenna analyzers that they'd like to tell us about?
W0ASP with a comment.
Go ahead, Terry.
My first antenna analyzer, handheld unit from a company called AEA, Alpha Echo Alpha, and that's an acronym for something I forget. And they have a handheld impedance analyzer called the Via Bravo. And mine's a little bit dated, but it does from a few kilohertz up to about 200 megahertz. It's actually a multi-channel analyzer, so it has like 100 different frequencies that it will record in a sweep. You can set the sweep start and step within limits, and you can save the information to a memory and then plug in a serial port and pull that information off to a computer. It also has a little small, hard to read LCD display. Let me let this drop. It has a few quirks, but as a true vector impedance analyzer, it gives you real and imaginary components, or the real and resistance and reactance, positive and negative. Has a few other features too. It can be a spectrum analyzer and a signal source. And of course it'll measure just straight SWR. So WASP back to net.
So Terry, if we could dive a little bit deeper into the vector impedance analyzer, what is the advantage to that over the standard antenna analyzer that's only giving you SWR?
Great number of things. First off, if you're only measuring standing wave ratio, you do not know if you are a resistive mismatched or a reactive mismatched. If your antenna was a 25 ohm antenna with no reactance, which is not a bad antenna, still gives you a 2-to-1 mismatch on a 50 ohm circuit. If you had an antenna with 50 ohms and say, I think about 100 ohms reactance, it would also give you something like a 2-to-1 SWR. Those numbers aren't quite right, but you get the idea. And then the vector analyzer will tell you if the impedance is negative, that means it's capacitive. If the reactance is positive, it means it's inductive. So you know if you're, for example, above or below the frequency, the tuning point or the resonant point of the antenna.
So is that more suitable for somebody who's going to be designing antennas for like production, or I imagine with the amount of testing that does, it's going to be a costly unit.
Not really, and not nowadays. I think that unit was $500 quite some time ago, and maybe it's still about that price. But there are similar units that will do vector analysis in the couple $100 range. I don't know the makes or models, nor have I used them, so I can't recommend them. But I know they're out there.
MIC.
Please go ahead, Mark.
Just for example, the little inexpensive $100 Mini 60 does all of what Terry says. So it gives you R and plus or minus J, and it will give you L or C.
So what is the L and C components?
If the antenna is too short, it appears capacitive, and you have to add inductance into the wire. If the antenna is too long, it appears inductive, and you need to put a capacitor on. And the meter will give you the value you need to clamp onto the base of the antenna between the conducting portion and the ground portion. So it's a very quick, how much do I need to add to make this antenna right, even if I don't have the ability to adjust the physical length of the antenna.
So where the antenna analyzer is going to tell you feedback on how much SWR you're having, the vector impedance analyzer is going to tell you more of why you have that SWR mismatch in the first place. Is that correct?
Precisely.
Very good. So then those you said it was the model was Mini 60. That was only around $100 on eBay.
All correct.
Any questions about either the vector impedance analyzer, which is I definitely want to see more about the vector and impedance analyzer. That's a very interesting thing, and or the antenna analyzer, just the general antenna analyzer.
ASP with a clarification.
Yeah, go ahead, Terry.
Sometimes we can get our terms confused, and just because something is called an antenna analyzer doesn't mean that it will not do or doesn't do the vector components. You do have to ask or check the specifications that it will give you both the resistive and reactive components, and ideally to give the sign plus or minus on the reactive components. That lets you know whether it's capacitive or inductive. So and something sold as antenna analyzer may in fact be a vector impedance analyzer. Just check the specifications. W0 ASP.
This is Whiskey Zero Delta Delta Zulu with the Northern Colorado Amateur Radio Club TechNet. Very good. What other components or test equipment, other than a good multimeter, are you going to want in the shack? Anybody want to share on that?
MIC.
Please go ahead, Mark.
The next piece I would suggest is a dummy load. You want to be able to run your transceiver into a dummy load. That's just a big resistor with a bunch of cooling fins, and be able to see how much power your radio says it's putting out and watch your radio's SWR meter, because the dummy load, and they are specific to frequency, so there are low-frequency dummy loads and high-frequency dummy loads, but for well under $100, you can get a 100-watt dummy load that will handle 160 meters through UHF. And your radio's SWR meter should be reading a perfect one-to-one. So you start by connecting your dummy load directly to the output of your radio, and then you work outward from there. First the radio, then on the far end of the coax where the antenna's feed point would be, and if you have one-to-one up to there, and you connect the coax up to the antenna and you have a terrible SWR, you know that the problem is the antenna, not the coax, not the radio.
Yes, being able to diagnose the problem that you may have is definitely a benefit. And you say they're only around $100?
More like 50 for a 100-watt load.
ASP comment?
Go ahead, Terry.
Yes, dummy loads are vital for testing transmitters, and they are frequency dependent, but as Mark says, if you're below a gigahertz, most of them are going to work. If you are suspicious of your dummy load, put it on your network analyzer or your antenna analyzer. And the other thing is, Surplus Sales of Nebraska has a number of them in the 50 to 100 watt range, and that's continuous. You can probably get away with a 5 to 10 watt one for short bursts of 100 watts of power, and those can be in the $10 range. W0 or ASP back to net.
So Surplus Sales in Nebraska, is that an outlet that you get a lot of amateur radio equipment from there, Terry?
Not amateur radio equipment. They have some used military stuff. I get components there. Some of them are high-end components. If you ever want something called a vacuum variable capacitor for tuning kilovolt transmitters. You can get them there. All kinds of somewhat exotic stuff, but fascinating look through on their webpage.
Yeah, I know you deal with a lot of the interesting radio equipment, so I figured I would figure out or ask about the surplus sales in Nebraska. That may have been one of your ham radio secrets, you know what I mean? Any questions about the dummy load that we haven't covered already? Now, so these are both components that help to figure out what's wrong with an antenna or a connection, something with your system that you already have in place. Now, is this good enough to start doing your own antennas and creating your own antennas, or is there more components that you will need for that?
ASP, I can take that.
Yeah, go ahead, Terry.
Well, I'm not sure this would fall in the category of test equipment. You'd need components like ferrite chokes and wire and insulators, and those are really antenna parts. Something I was going to add that needs to go in just about anybody's shack are patch cables and RF adapters, because you're going to have to deal with equipment that has PL259s of different sexes. You're going to have to deal with BNCs of different sexes and probably SMA connectors, and maybe even throw in ends depending on what frequency you're working. So having a collection of adapter hardware and patch cables is an essential component of any shack for doing any kind of testing.
Yes, that is a good point. Connectors and adapters is definitely going to be important. So my question then would be, where do things like spectrum analyzers come in? When is it that you need that grade of a diagnostic equipment?
MIC.
Go ahead, Mark.
Dave, first, there was a double underneath you when you began.
Yeah, that was ZFF.
Very good. Let's take Mark first, and then we'll come back to the other. Well, okay, I'm sorry. Let's take Whiskey 2 Mike India Charlie first, and then we'll come back to KF5 ZFF.
W2MIC. A spectrum analyzer is quite a ways out there in terms of what people need. They're nice, don't get me wrong. They're also expensive. The next test component I would suggest, or the next test device, would be a power meter. And I have a Bird watt meter with the appropriate slugs for all the bands and power levels that I can use, and the full adapter kit that lets me build anything to anything adapters. A less expensive option is a cross-needle SWR and power meter. And this is they're in the really good diamonds, I think, are in the 150, 180 range, and the MFJs are down more like 100. And this is a meter that has 2 needles and 3 scales. One scale reads output power, that is to say, from the radio to the antenna. The second scale reads reflected power, power coming back from the antenna to the radio. And where those 2 needles cross shows you an indication on the third scale, and that is your SWR. And they are really nice to have, both as test equipment and to just plain have in line with your radio on the way to the antenna at all times, so you have an instant visual indication if something has gone awry.
And KF5 ZFF, please go ahead.
Yes, before you were talking about the spectrum analyzer, I was going to say, as evidenced by my current signal, that having a extra ground lead that you can use when your example at a KOA park running power from your RV that has some kind of a ground loop in it, that could come in very handy as a diagnostic tool, along with a ohm meter to make sure that your ground isn't I guess an ohm meter and a amp meter to see if you're actually transmitting anything to that ground. So sorry for the noise in the background. KF5 ZFF, back to net.
Oh, no worries, Mark. Your signal is much clearer now. So the power meter, Mark, you said so that really, are you gonna like determine what kind of losses you have in the feed line? Is, I guess, one way you know what the or one use of the power meter. What else is it capable of, and where would you use it?
Well, the primary use is monitoring outbound power and reflected power, and SWR comes from an equation that is the relationship of power output and power reflected back. So if you have a straight power meter, like a bird, you take two measurements, outbound power and reflected power, and then you either use a little graphical tool or you crunch it into your calculator to compute SWR. The advantage of the cross needle devices are, one, they're less expensive, much, than a bird plus all the different frequency-specific plugins. Two, they show you in real time both transmitted power and reflected power, whereas with the bird, which is a lab-grade instrument, you need to turn the indicator device for outbound power. You can then measure outbound power. Then you have to physically turn the slug to inbound power, and then you can measure inbound power. So you cannot simultaneously measure the two. A cross-needle device will show you outbound power simultaneously with reflected power, simultaneously with SWR. So it's everything you need to know about inbound and outbound power at a glance. With respect to other stuff, we would fall back to antenna analyzers, which can do cool things like tell you how far down your coax the fault is, but that's a different question.
So the cross needle power meter / SWR meter is really gonna accomplish the same thing as a power meter, just at a glance, doing all of those calculations at the same time. And you said Bird was a very good quality power meter. Is that so expensive because of it being lab grade equipment?
Yes, new they run in the $500 to $800 range, whereas the decent cross needle meter from MFJ will be under $100, and the good ones from Diamond and Comet will run $150, $180, somewhere in there.
So you got your antenna analyzer, or even better, the vector impedance analyzer, and your dummy load, and your cross needle power meter. What else do you need in order to make sure? And all of these components really look at analyzing the antenna. Is there stuff that you should have to determine problems with the radio, or some case like that?
Yes to all the above, and then I'll pass it to Terry. I've gone very happily for 25 years with a voltmeter and a primitive antenna analyzer, the old MFJ 259, and I've built anything and everything from VHF cubicle quads to dipoles to you name it on HF. The cross-needle power meter is really more oriented towards operation. It's not so much an antenna building tool.
Okay, Mark, and I'll pick that up. I would never crack open my radio without an oscilloscope and a couple of 10x or even 100x probes on hand, because once you start getting inside of your equipment and starting to figure out what's wrong with it, the stuff we talked about now will tell you, oh, my antenna's fine, but the radio's broken. Then you need to find out where the problem is. And as you open that up and maybe you get the schematic and try to work your way through the reference points, you are going to need more than an ohm meter and a voltmeter. You're going to need to be able to measure RF levels, and therefore an oscilloscope is essential. I'll let this drop. Like with most things in the last 10 years, there has been quite a revolution in performance and capability versus cost from some of the Chinese suppliers. And like Rigol and Owan make some very good oscilloscopes in the $300 range. W0 ASP back to net.
So when are the circumstances that you would need an oscilloscope versus a spectrum analyzer? Where do they differ, and where would you need one over the other?
Well, an oscilloscope will pretty much only give you the amplitude of the primary signal. So if you have a, say for example, you were to hook your oscilloscope to an antenna around here, say it's your HF antenna, you'll probably see one of the AM broadcast stations, whichever one is closest to you, dominating the output. You will not know how much of the signal contribution is due to an AM station, how much is due to WWV, how much is due to lightning, etc. So it gives you no frequency domain information. An oscilloscope is a time domain instrument.
Terry, would you consider an SDR to be a diagnostic instrument?
Absolutely. I have one of the Hermes boards from the Tucson Amateur Packet Radio Group, TAPR, and I can hook it up and use it as a spectrum analyzer up to 60 megahertz. I also have an impedance bridge, so I can use it as a vector network analyzer, and a very nice one too, up to about 60 megahertz.
Well, I have an oscilloscope, but not an SDR, and boy, an SDR just went to the top of my bucket list.
So, yeah, SDRs are amazing little things. All I've had is the little $20 SDR that is just one of those USB dongle style SDRs. Is that similar to that, or what kind of an SDR are you talking about, Terry?
With the correct software to act as a spectrum analyzer.
Ooh, I'm sorry, Terry. I doubled with you. Go ahead again.
Terry 1.
That doesn't surprise me, being in Greeley. You guys are a lot closer. Well, Terry's not, so you must have a better signal than I do. So my question was, or my statement was, I have definitely got to play with an SDR. That's actually what got me into amateur radio, but I've only got to play with the $20 little USB dongle SDR. What kind of investment do you have in your SDR? It sounds nicer than my $20 thing there, Terry.
Oh, yeah, that Tapper board was a cool grand.
Yeah, these days there's the HF Plus in the $200 range.
Yeah, there's a few that are in the $200 range, the AirSpy, and then the HF Plus. Yeah, there's definitely a few of them, and I guess that's kind of what I was trying to gauge. Will the $200 SDR do some of the functionality of the nicer one that you have, Terry?
Well, some of the functionality, and you have to remember the SDRs were intended as communication receivers, not as test instruments. There are a number of electronic characteristics such as third-order intercept and harmonic distortion that come into any receiver, and you have to make a balance between what the receiver you're going to use is and what your requirements are. In using SDRs as spectrum analyzers, you have to be very careful that what you're seeing is not some kind of artifact of your receiver. But that's also true of almost every spectrum analyzer.
DAS.
Go ahead, Dave.
Well, I've been listening intently to the conversation and just keeping tabs also on the cost that everybody's talking about. Is there any talk amongst the Northern Colorado Amateur Radio Club about getting some of the test equipment that we would, want to have access to, but don't necessarily need to have access to all the time? Would that be something good for the club to think about purchasing some of these things? Because, boy, it really adds up when you start thinking about it. Back to you, Dave. W0DAS.
I actually think that the club does have some test equipment that is able to be loaned out. I'm going to have to touch base with Joe about that and figure out what we have, because, yes, that's true. I mean, you wouldn't necessarily... I guess there's some stuff that you would want, like the cross-needle power meter that would be good to have plugged in all the time. But a nice... antenna analyzer or vector impedance analyzer, stuff like that, is something that the club may actually have and have the ability to loan out. I will touch base with Joe on that and see what I can figure out in that regard, because maybe that's just a marketing issue.
No, I agree. I think that there's certain equipment you need to have, but I was thinking some of the more obscure equipment that they're talking about tonight. Just a thought, and would love to have a hands-on demo of this as well sometime. So I'd like to learn more. Back to you, W0DDZ, W0DAS.
Yeah, I mean, I guess a lot of my curiosity on the spectrum analyzer comes from going over to Marty's place and watching W0LEV Dave make a filter for he's very close to a FM broadcast station, and that was just kind of stomping over everything. And so using the spectrum analyzer and cutting some wire, Dave made a filter, and it just made the thing a box of magic. So yeah, it's definitely something that I'm very curious about also. This is Whiskey Zero Delta Delta Zulu with the Northern Colorado Amateur Radio Club Technical Net. Any other questions about the spectrum analyzer, the oscilloscope? We went over the cross-needle power meter, or just a standard power meter, the dummy load, the vector impedance analyzer, which could also be called a antenna analyzer, but it just has some more functionality. Any questions on any of those topics?
W0ASP with a comment.
Go ahead, Terry.
I'd like to respond a little bit to Diaz's comment, and once you start getting test equipment that starts costing in the several hundred to several thousands of dollars, it also requires some amount of expertise and experience to run it. And, I'd hate to have to, I've blown my share of equipment in my day, believe me. If I had to pay for it all, I'd be broke. But I think in the spirit of amateur radio and Elmering, those of us who have that kind of equipment would be very happy to come help those who need it, not only with the equipment, but bringing also our experience, because I think that's also part of the amateur radio principle and philosophy, is to not just have the equipment, but to share the education. W0ASB.
MIC.
Go ahead, Mark.
W2MIC. Terry beat me to it. I am going to plug the NCARC Elmers program. This is a bunch of people who are experienced hams, and they will, upon request, come to your location, varying equipment, certainly including antenna analyzers. And part of the bit with an antenna analyzer is, as Terry suggests, and they know how to use it. So they can take an eyeball, look at your antenna, clamp an antenna analyzer on, and tell you what's wrong and how to fix it. Whereas, boy, when I got my first antenna analyzer, it was like, oh, I took a reading. Oh, that's nice. Now what? Similarly, there are several hams in the Elmers program who have much more sophisticated equipment and would be justifiably reluctant to let an amateur, I don't mean amateur radio operator, I mean amateur electronic operator, touch it. Those are expensive pieces of gear, and it's not at all hard to blow them up.
Yeah, I definitely agree with taking care of the equipment and keeping it in working order and having somebody experienced in using it to help operate it and teach the younger generation of amateurs how to use the equipment and when they're useful. Like I said, my only experience seeing a spectrum analyzer was very brief for a very specific purpose, and it just seemed like a box of magic, you know what I mean? So it's definitely something that I want to learn more about for sure. So you have your antenna analyzer and your dummy load and your cross needle power meter and a good Elmer with a spectrum analyzer and an oscilloscope. Are you ready to deal with any problems that may come up, or is there some other equipment that would be beneficial to have in your shack at your disposal?
Well, it would be nice to have a device that will measure the actual value of a capacitor or an inductor. Middle-end meters will do that, like the $600 or $800 Fluke multimeters will do that.
Oh, yeah, now we start getting into some really interesting stuff. And I'm a particular fan of 1980s vintage HP equipment, and they make something called an LCR meter, inductance, capacitance, resistance meter, that is good to better than 0.5%. And a wonderful piece of equipment, but it is a typical HP boat anchor, W0ASP.
Now, and that's going to be stuff that you would want to figure out what is wrong inside of the radio, or what else is that going to accomplish, having the ability to measure capacitors?
Building filters.
Ah, very good. Yes. Filtering, which is kind of where the spectrum analyzer had come into play with Dave, W0LEV. He was building a filter using the spectrum analyzer. So where are you going to use the LCR meter versus the spectrum analyzer in filter designer? Is the oscilloscope able to also measure caps?
Not really on the oscilloscope. An LCR meter, and I know the one Terry speaks of, lets you take a device, whatever the heck it is, and measure its resistance, its inductance, and its capacitance, and any device may well have all three. If you have a spectrum analyzer, and realize, of course, that a spectrum analyzer is like several orders of magnitude more expensive than anything else we've talked about, you don't really care what the values are because you can tweak and see what the results are, and that's what really matters. What we haven't talked about yet is running antenna modeling programs and then building antennas. And when the antenna you built doesn't match the results of your modeling program, what do you do and how do you measure it? And that is where a spectrum analyzer absolutely shines.
Okay, I see. So really, like, the spectrum analyzer is just so functional that it can cover a lot of the uses of a lot of the other stuff in one box, but it's orders of magnitude more expensive. What kind of a price are we talking about entry-level spectrum analyzers?
Ooh, Terry, you're more current than I am. Back in the day, 20 years ago, a good HP spectrum analyzer started at $20,000 and went way up from there. In the used market, I have a buddy who 20 years ago bought one for about 15 or 17 grand and thought he got a roaring good deal.
Well, like I said before, the revolution in the Chinese market, where I think they've stolen a lot of the technology from the American companies, but instead of Rigol, let's just say I just recently got a Rigol 3 gigahertz spectrum analyzer for about $3 grand, and that includes a tracking generator. So that's an order of magnitude less expensive than a U.S. brand.
So I have definitely got the opportunity to play with a Rigol oscilloscope. Would you say that the Rigol brand on the spectrum analyzer is pretty good quality and that they're fairly accurate?
Well, I think the one that I got is fairly versatile. I'm sure that there are probably some differences in performance compared to that versus what I would say is if you got an equivalent machine from what is now Agilent or Keysight, would be 50 grand, certainly $30,000. There's got to be some difference in the performance of the two, but I would have to lay down the money to find out the difference.
Yeah, talk about a bill that hurts for sure. 50 grand, wow. But yeah, like the $3 grand-ish isn't actually very bad for a such a functional device. And I know that, yeah, I've seen Rigols and oscilloscopes in the $300 to $400 range that get quite high marks.
Well, and I get a lot of this from my mentor, Dave W0LEV, who's been mentioned many times on this net, and he's helped me a lot. One of his recommendations, and I ended up getting a piece of used HP gear, again, 1980s vintage. It's a 3585A spectrum analyzer. It only goes to 40 megahertz, but its dynamic range is, I've hardly ever been able to exceed its dynamic range. It is a wonderful instrument. I think it weighs 100 pounds. It's gone into my rack once. It's never coming out again. But I said I got it for, it probably went for 40 grand when it was first made. I picked it up for 1,000.
This is Whiskey Zero, Delta Delta Zulu, net control for tonight's Northern Colorado Amateur Radio Club Technical Net. Tonight's topic is diagnostic equipment. What do I need in my shack? And we have covered the antenna analyzer or vector impedance analyzer, the dummy load, a cross needle power meter, a capacitor measurement tool like an LCR meter, an oscilloscope, and a spectrum analyzer. So, Mark, you were talking about antenna modeling programs and using those to build antennas. Is that very costly, or do you have a program name to throw at us?
Oh dear, I'm hardly up to date. They range from free up to several $100s up to a couple thousand. EasyNEC comes immediately to mind, and there are several others. These are more for, these are not for modeling dipoles or verticals. These are for modeling funky J-poles or odd devices or multi-band no-tune antennas, etc. I've managed to resist getting one and playing with it. First of all, because I really only work with fan dipoles if I can help it. And secondly, because it would be an incredible time sink. Now, the good news is that with any of these programs, lots of people contribute their work, meaning the antennas they have designed and hopefully built and tested, to some online available free libraries. So if you have a specific need, you may well be able to find somebody else has built or designed and built one of those for you. And that's where the modeling programs are just tremendously useful. For me, I haven't really felt the bug.
So would you have a name to drop for a website where you could go and look at the various antenna designs?
Oh, I would start with EasyNEC, Echo Zulu, November, Echo Charlie. That's the oldest and one of the most versatile. Just go looking for EasyNEC antenna designs, and Google will bring you back tens of thousands of results, literally.
Very good. Yeah, I'll definitely have to go digging into that. So let's dive a bit into the deep end. And I know, Terry, I've talked with you a bit about using a quadcopter to map an antenna's output. What kind of equipment is involved in doing something like that? Because I know you were talking about wanting to be able to do that for the observatory there. So what kind of equipment would you need on the quadcopter in order to do something like that?
Well, Dave, I'm going to have to preface this with the fact that this is all just ideas, and I've never done this.
Oh, yes, absolutely. Yeah, that's what I kind of meant by diving off the deep end.
If you want to map an antenna pattern, that you would put a small, low-power emitter and a battery-operated transmitter hanging under the quadcopter, and you would fly it around. And as you flew the source around, you would measure how much signal came out of your antenna. Actually, quite frankly, the amount of equipment necessary to do that is relatively simple.
No, very good. So I was thinking the opposite, that you would need the receiver on the quadcopter and you would be transmitting from the antenna, but I guess it definitely makes more sense to do it the other way around.
Oh yes, I don't think your quadcopter could lift the amount of equipment necessary to not only receive the signal, but to record it so that it could be analyzed afterwards.
Yeah, that definitely makes sense. So, short of that, how would you accomplish the same task in the real world without the benefit of like a quadcopter?
Well, I think in truth that most hams don't have a scientific or an engineering idea of how their antennas radiate. And this is very understandable because antenna patterns are complicated by interaction with the ground, where you hang it, if it's above your roof. That is a complicated thing where antenna modeling software can come in and help. But the antenna modeling software I found, gives you a basic idea, but you always have to fine-tune it and figure out what you actually have once you put it up.
Yeah, and that brings into play how you would know that the modeling software is very accurate if you can't map it. I mean, I imagine that they're just doing theory and using some math to figure out how the antenna would radiate. I'm guessing.
Contact.
Oh, I heard another station in there. I didn't catch who it was. Go ahead.
Yeah, this is W0USC. I was just listening in. In the commercial world, you'd use a field strength meter, and it would be calibrated. I've spent a lot of time going out in the field and taking readings for commercial broadcast, AM and FM.
So is that like the opposite way? So you're actually receiving the signal and classifying it that way?
Correct. Yeah, you'd use your normal signal source, and you'd go out in the field and take meter readings at different directions and different distances.
So, and that's how you're confirming that the modeling software has been accurate in its model of the antenna.
Yes, but more importantly, you determine what the real radiation pattern is. So if you have a directional pattern that you're setting up, or like a directional AM broadcast, you want to make sure that you're sending a signal in the right area.
Yeah, and I imagine in the commercial world where they're working with kilowatts instead of just watts, that gets to be very, very important. What other test equipment do you use for that sort of job?
That's pretty much it. Just one piece of equipment, just a field strength meter that's calibrated. And you go out and take GPS readings or mark on a map where you're at and write down the reading from the analog meter.
PRB.
Evening, Phil. Go ahead.
Yeah, consider me checked in, Dave. I'm kind of curious as to how one measures the output of an antenna in the vertical horizon or vertical direction. So you can stay on the ground and know what it is there, but what about the altitude or the direction?
USC, do you want to comment on that?
I've just done stuff on the ground, but yeah, I'm sure you could take those readings, abroad or aboard on an aircraft or a balloon or something, of course.
Well, and that's where I was guessing that the quadcopter would come in handy, and I'm sure Terry was thinking the same thing. This is K0PRB.
So how large is the field strength meter?
Oh, it's probably been 30 or 40 years since I used one, but at that time, it was a small box, half the size of a briefcase, roughly.
Very interesting. Yeah, that definitely sounds like a load that a large enough quadcopter could carry, and yeah, you could definitely do some vertical mapping. How far away from the source are you? Have you been in your experience when you were doing that sort of mapping?
This is W0 USC. I've just done kind of local work, but I know people have done regional stuff, especially like nighttime AM. It propagates quite a ways. But I would think some type of, back to the quadcopter, I would think some type of SDR with some type of logging software might get you what you need.
Yeah, it's definitely very interesting to me hearing kind of what the commercial side of things has used to accomplish some of this stuff. I mean, I know we're going well beyond the average amateur Radio Shack, but it's definitely interesting to know some of that top end gear that is out there and how it's used, whether it be commercially or by very good amateurs. So, and just to summarize, we've covered the antenna analyzer and its similarities and sometimes called vector impedance analyzer, or they serve the same function, or sometimes they will be called a antenna analyzer when they do the vector impedance component, which is the resistive and reactive components of it. We've talked about a dummy load and a power meter. What is really nice is the cross needle power meter. We've talked about a cap measurement tool like an LCR meter, and a oscilloscope, a spectrum analyzer, antenna modeling software such as EasyNEC, and calibrated field strength meters. All very interesting tools that I definitely want to learn more about. Is there any other test equipment that we haven't covered or that may be useful to one in a shack? I mean, I guess we also covered an SDR and its similarities to a spectrum analyzer. Any other equipment that we haven't covered that may be useful to somebody in their shack?
ZFF?
Yeah, go ahead, Mark.
I think we might have forgotten the most important piece of equipment, and that's called an Elmer, who has all that gear to begin with.
Yeah, that is a good point. I hear of stories in the past where you kind of got paired with somebody to start your amateur radio adventure, and it seems a little different in today's day and age. I know we do the Elmer's group, which is available to anybody. It is Elmer's at NCARC.net, and you can ask questions or advice, and even ask for some help with people to come over with their test equipment and help figure it out, given that it's local. But it doesn't seem that you get quite paired up like you used to in the past. Is that anybody else have observations on that?
Well, this is ZFF again. I managed to get a buddy who doesn't know what a spending limit is to get into the hobby, and he does it all or nothing, and he's in probably for 30 grand a gear since he started 2 years ago. So find yourself someone that's got a lot of money and that has a lot of interest, and you'll be in great shape. KF5 ZFF.
Yeah, that's always a nice thing to find, and the experience is definitely key. I know I've seen, like we were talking about Dave LEV and his use of the magic box or making the spectrum analyzer or do some magic. Yeah, any other test gear or anything that anybody wants to add to the conversation?
RXF.
Yeah, go ahead, Randy.
Well, being a newbie, I'm reading and ogling all this gear and all of that stuff right now. And the thing I see mentioned a lot are antenna tuners. Is that the same thing as the antenna analyzer?
W2MIC, do you want to kind of cover the antenna tuner?
W2MIC, sure. More properly, they're called a transmitter match, since what they do is the transmitter has an output impedance of 50 ohms, 50, and it wants to see a coax and antenna which present a 50 ohm load. In the real world, antennas very rarely present a 50 ohm load. So what a transmatch is, or they're often called antenna tuners, it is a antenna analyzer in a box with a whole bunch of relays or switches and a whole bunch of different values of capacitors and a whole bunch of different values of inductors. And when you trigger the transmatch or the antenna tuner measures the SWR of the antenna as seen from the radio's end and begins switching in and out different values of capacitors and inductors, working to find a way to lower the SWR to an acceptable limit, usually 2 to 1, sometimes 1.5 to 1. And so there will be a great flurry of clicking as the relays kick in and out and the various values are tried. And then when it's done tuning for an automatic tuner, it will give you either an acceptable SWR, like 2 to 1, or it will say, I'm sorry, I can't match this antenna adequately. So an antenna tuner, or a transmatch, is both an antenna analyzer and an antenna fixer. That is to say, it presents the necessary capacitances and or inductances to let the radio think it's seeing 50 ohms. And then the transformation networks inside the box are altering the impedance. And whatever you have out there for an antenna then looks to the radio like a really good match, even though it may not really be. Some antenna tuners are designed for symmetric antennas, like half-wave dipoles. Most of the radios that have a built-in tuner will tune a range of an SWR of a maximum of 3 to 1. Other tuners will do more like a value of 11 or 12 for SWR.
That is a much more elegant response than I could have given. Yeah, and from my understanding, the antenna analyzer and how it is used is kind of to diagnose and categorize a antenna so that you can see where your transmitting range is, where the tuner is a device that's always plugged into your radio that is going to, like Mark says, match the impedance of the antenna to the radio. So often you'll need an antenna tuner in order to get as much use out of an antenna that you can, because the antenna will have a point at which the SWR is acceptable, and it will curve outside of that acceptable limit. And as it does that, it'll get to a point where it's outside of the ability for your radio to be able to tolerate that that amount of SWR that's getting returned to your radio.
Okay, thanks. Yeah, that helps me understand the difference.
Another point I guess I'll add is that though it does do analysis on the antenna, it doesn't necessarily give you much feedback on the analysis, where the antenna tuner is all about giving the feedback to you so you can make adjustments in the antenna. So for example, when Bart came over to help me with my antenna, we found that the curve was, or its lowest impedance point was so low on the 40 meters, for example, that half of the good 40 meters was outside of the amateur range. So we were able to make adjustments to the antenna, shortening the antenna essentially enough to move that curve inside of the amateur range so that I can use all of 40 meters with an acceptable SWR. This is Whiskey Zero, Delta Delta Zulu, Dave with the Northern Colorado Amateur Radio Club TechNet. Do we have any other test equipment or anything that we have missed covering tonight that anybody wants to throw in there? Please call now. We seem to have an open mic. There was another station that tried to come under that open mic. Are you able to get over the top of that? Yeah, it looks like the open mic cleared. There was a station in there that wanted to throw something in. Please come again.
W0 USC.
Yeah, go ahead.
So if you get pretty deep technically into building radios, going through all the different modules or pieces of how to build a transceiver, receivers and transmitters, you need a critical piece of equipment called a service monitor. What that does is provide an RF generator and ways to, an oscilloscope and other ways to read the signals so you can actually build and tune the circuits.
So how does the service monitor differ from like the oscilloscope and the spectrum analyzer?
It has a signal generator in it, first of all, an RF generator. And it does other measurements that are needed. Some of them do phasing, so you can see the phase of stuff. A lot of scopes allow you to do that also. It just depends. These pieces of equipment are pretty expensive, the new ones. At least the ones I saw were 20, 40K.
Well, yeah, so that's really getting into the top end of gear. And is the RF generator something that you can get as a standalone device, or is that generally included in the service monitor?
No, you can buy those as standalone test equipment, like from Hewlett-Packard or Elecraft actually has a little low-power one. But I've got a service monitor that's pretty old, but the way I used it was to retune some VHF, UHF radios from the commercial band into the amateur band.
Okay, I see. So yeah, you can use it to generate the RF and then use the measurements to tune the radio into the opposite band, as I'm gathering it.
Yeah, that's probably the simplest way to say it.
MIC.
Go ahead, Mark.
They are absolutely essential for repeater maintenance. KI0KN has one, our tech chair. You might ask to get a tour.
Oh, KI0KN has many things that I would like a tour of. He's a busy guy though. It's always a patience game getting him to have the time to show me around all of his cool things.
Yeah, so that would be useful in tuning the receiver, the transmitter, and also the duplexer.
Now, is that the only tool that is good enough to actually do that work, or is some of the other equipment that we have capable of doing it?
A modern service monitor is sort of an all-in-one tool, at least the way I understand them. I haven't got to play with any recent ones, but the old ones that I've done, they were sort of built as an all-in-one solution.
Dave, you can certainly do all those things that a service monitor, a system in a box, does with individual instruments and lots of cables.
I see. So really it's bringing all of the stuff that you need for that work into a single device.
Exactly, and just what you need to do radio work, not a general purpose instrument bench.
Very good. And how big are those things? Are they pretty large?
So the modern ones are maybe half a foot by a foot and a half wide, and maybe a foot or foot and a half deep. I'm just guessing. I've got one that's a Cushman from the 1960s. It's all tube. It's real heavy and real big.
Yeah, Dave, the ones I've seen, the relatively modern ones, are like 5 to 8 rack units.
So fairly large devices, it would be easier to pull the repeater and all of that stuff out and bring it down to the bench than bring the service monitor up, is what I'm gathering.
Most commonly.
Very good. Well, this has all been fascinating. We've covered the antenna analyzer or vector impedance analyzer, the dummy load, the cross needle power meter, the LCR meter, the calibrated field strength meter, the oscilloscope, the spectrum analyzer, and the service monitor, and your friendly Elmer to show you how to use that stuff. Is there any other test equipment that we'd like to throw in there?
ASP?
Go ahead, Terry.
Well, some of this may be a little bit redundant with some of the other components. However, a good signal generator that you can change the frequency of and preferably have a good frequency reference to it is a component of measuring signals. For example, it could be used with an oscilloscope to have essentially a poor man's spectrum analyzer or network analyzer, where you put in different frequencies to the input of your circuit and use your oscilloscope to measure the amplitude of the output and possibly even phase if you hook them together correctly. So with a little bit of cleverness, a signal generator and an oscilloscope are a spectrum analyzer or a network analyzer.
Now, is the signal generator and the RF generator the same thing, or are they different things?
I'd say the same thing. I use a signal generator, presuming that it's RF, not audio frequency.
Very good. And any other test equipment that we haven't covered? This is all going to be a bunch of Googling for me. This is all very fascinating.
ZFF?
Go ahead, Mark.
I seem to be giving the very common sense, simple things, but just having another radio around. Like tonight, I had a HT along with the space station, and my wife was listening to it on the same frequency, just to hear, to see, oh, is it picketing? Is it noisy? Is it crackling? There's a lot of things you can tell by just having another radio, especially if you don't have the budget or the other equipment around. A lot of times, just another radio simply there, you can tell what's going on.
Yes, that is very true. Lots of us will run a second radio to hear that our signal is very, or what's going on with our signal. It does, there is a bit of a delay on this repeater, and sometimes it gets kind of hard to listen to that, but for a diagnostic purpose, yeah, that is a fantastic tool to bring to bear. Yeah, anything else that we've missed on this list?
AE0BQ.
AE0BQ, go ahead.
Right, I've been listening for quite some time. I didn't hear an opportunity to do a late check-in, so I just jumped in. I happen to have the Regal spectrum analyzer at the lowest end of the low end, except that it does have the tone generator, the tracking generator, and it ran about a little under $1,500, and it does all the way up to 1.5 gigahertz, which, pretty much, unless you're into that high frequency stuff, that'll cover everything you're going to do in ham. And I'm not championing Regal here, but there are a number of competing brands at this level, but they have scopes that go up to 200, 300, 400 megahertz for well under $1,000. And I just wanted to give that as a data point. I hear numbers like 30,000 and 50,000 being thrown around. Well, yes, for name brand, made in the good old USA, professional level test equipment, yeah, it's very expensive. But some of the Chinese brands, O1, Siglent, Rigel, some other ones I can't think of right now, but are competing on price, and we're the beneficiaries of that market force. That's all for me, AE0BQ.
Yeah, thanks for that. Yeah, Rigel has definitely come up a couple of times, both in oscilloscopes and spectrum analyzers. And yes, it is very nice that somebody is bringing that cost down just so that we can get it into our hands. It's very helpful. Any other test equipment or any other comments on diagnostic equipment for your shack before we close up the net?
MIC.
Go ahead, Mark.
W2MIC. Dave, the question you have forgotten to ask is, what is your most commonly used piece of diagnostic equipment? And at least in my shack, my most commonly used instrument is a Baofeng UV5R. To answer the question, am I actually transmitting?
Yes, that is a good point. Yeah, and let's move that around. Terry, what is your most common used piece of diagnostic equipment? W0ASP.
Hey, Dave. Far and above my two most commonly used pieces of test equipment, that used in conjunction, are my rubidium oscillator and my frequency counter. The station always has to stay on frequency. We never got around to that. W0ASP.
Ooh, do you want to elaborate a little bit on that? I'm guessing that's for your the astronomy stuff. So do you want to elaborate a little bit on what that is and how you use it?
Yeah, the rubidium oscillator is a very precise 10 megahertz oscillator that uses the physical nature of the chemical rubidium and its natural resonance to generate a precise 10 megahertz reference, and that goes into my frequency counter. And yeah, I do use that in particular with the receiving the meteor scatter to know that my receiver is on frequency.
Very interesting. Yeah, I mean, you're doing radio astronomy with the Little Thomson Observatory, as well as some stuff with NOAA, and I know you get into some very, very cool pieces of equipment for sure. Let's see, Mark, KF5 ZFF, what is your most commonly used piece of diagnostic equipment?
Yeah, this is KF5 ZFF. I think I agree with MIC that a second radio is primarily what I use. I've got some of the other equipment, and with my disaster incident response team truck, we have like every piece of equipment that's been mentioned tonight. So that's, it's like going to a candy store when we go into that thing. But I usually end up just using another radio. I will say that when you get into the higher bands, into the gigahertz, which is a lot of what I have to do with dirt for the satellite transmissions and the LTE and stuff like that, we have to get into some very fancy analyzers that most, they get outrageously expensive. But in the end,
another radio, and sometimes if we don't have the frequency generator, going into the diagnostics into a telephone, which will tell you all that information too. Sorry for going long. That's all. KF5ZFF.
Oh, no, we definitely appreciate your input for sure. W0USC, you definitely sounded like you had quite a bit of experience in the commercial field. What was your most common used piece? I'm guessing it was the calibrated field strength meter back then. What about now? What is your most commonly used piece of diagnostic equipment?
So aside from a volt-ohm-meter, probably a secondary receiver on the frequency that you're playing with or working on.
Yeah, that definitely seems to be a popular theme, and for me personally, that's definitely been what I've used most of all. I've only had the opportunity to really play with a couple of these other things very few times. Once, obviously, to help get my antenna classified and just really seeing the spectrum analyzer. So for me personally, definitely a second receiver is by far the most common piece of equipment that I've used. Is there any other stations who want to talk a little bit about their most used piece of diagnostic equipment? I know there's several others that have been listening. I've kind of just covered the people that have had the most experience in this. So any other stations who want to cover that? Was there any other diagnostic equipment that our list did not cover?
MIC.
Yeah, go ahead, Mark.
Yes, the poor man's frequency reference, WWV.
Ah, yes, that is a good point. They are commonly transmitting on, I think 2.5, 5, 10, 15, and testing or 20 is in the beta, I'm pretty sure. But yes, that is a good point. They definitely are a great frequency reference.
And Dave, there was
AE0BQ.
AE0BQ, go ahead.
Right, just wanted to mention there are really inexpensive SWR reflection bridges. So you can, with the spectrum analyzer, you can measure the reflected power from your antenna, and it's a cheap. If you don't count the cost of the spectrum analyzer, again, you can get low-cost ones for $1,500. Yeah, it's a great way to visualize the overall response of your antenna system. From the point of connection at the radio. That's all. AE0BQ.
I haven't actually heard of that one. Does that plugs in between your radio and the antenna system, I'm guessing?
Right, it's a directed port device. There are some companies that specialized in making those, customized to particular frequencies. There's one that I bought from. I haven't hooked it up and used it yet, but I'm itching to. It's 0.1 to 3,000 megahertz. Well, that's what the claim is. $15 on eBay, and it's got a series of SMA ports. You basically hook your signal generator in one port, your antenna in the other, and then you sort of measure on the third leg, one of the third legs. I think you hook a dummy load to the third leg, and then you measure the fourth leg, and that's supposed to give you the reflected power, or return loss is actually the correct term. But so it's a basically one-way one-way switch, if you will, for RF. AE0BQ.
Yeah, that is a very interesting one. I'll have to Google that one for sure. Any other test equipment that we haven't covered? Ah, very good. Yeah, like we've gone a little long, but I do definitely want to ask if anybody has any questions outside of the topic of diagnostic equipment for the very, very smart people that we have on the net tonight that are contributing. Any questions for the net? Any at all, not just limited to diagnostic equipment. Hearing none, I want to thank each of you for being on the net, and a definitely big thanks to our contributors there that have shared such great information with us about testing equipment. You know, I'm fairly new in the HF, and I haven't done much testing with the UHF, VHF stuff, so I'm just really personally starting to dig into what kind of equipment that I need in order to be a better ham, I guess is a good way to put it. And I really appreciate all of you guys contributing to the net tonight. I am going to leave the topic to Kevin to pick, but if you do have a suggestion for the net or a topic you want us to cover on this net, please email them to elmers@ncarc.net. We are always interested in topics that you guys have. Often they are great topics that get well dived into. Anything further by any stations for the net, please call now.
ASB?
Yeah, go ahead, Terry.
I want to welcome Mark, KF5ZFF, to the repeater and thank him for his presentation this evening. It was informative. I never knew that you had that kind of program over at Cisco. So thanks and howdy.
You're welcome. This is, I'm sorry, breaking net protocol, but glad to help, and well, you can take a look at the website, and anything we can help with out here, let us know. Again, we're pretty much all just volunteers like y'all. Thank you, KF5ZFF.
Yeah, I definitely want to second that. That's very interesting. I never knew Cisco had anything like that. And yeah, Thursday we definitely have the amateur radio emergency services net for this area. That that would be great if you have the opportunity. I know you're just visiting town, but if you're here on Thursday at 7, that would be great for that group too. I'm sure there's plenty of people there that would like to hear from about that. Any other comments for tonight's net or any of the people on board? Hearing none, I definitely want to thank everybody for participating in the net tonight and making it a really very interesting topic for us tonight. And this net will happen again, given that there's not severe weather getting in our way again. On this repeater, next Monday at 7 p.m. And our NCARC ClubNet that we encourage everybody to be a part of, member or non-member. We definitely love to hear from you. That is taking place on Wednesday. Early check-ins start at 6 and the net starts at 6:30. Thank you guys for being here. This is Whiskey Zero, Delta Delta Zulu with the Northern Colorado Amateur Radio Club TechNet. The repeater is now open for general use. This presentation was brought to you by the Northern Colorado Amateur Radio Club. Thank you for watching, and don't forget to like and subscribe.